So this is one of the more complex projects I've done using Python and the Arduino modules. It actually involves 4 programs running, 2 Arduino sketches and 2 Python sketches. Over here on the left, we have the object recognition and detection of real-time video. And over here on the right, we have a Gui interface written to control the robotic arm, and which has the video for the object detection and recognition located on the gripper. In addition to that, as we find objects in the video, the EasyVR3 module will say that object out loud, what it is. Also, as items are detected and spoken, and the GUI is moving the robotic arm, the LEDs will indicate what's going on. So that's more of a debug process. Over here, I have a little bit of a debug process going on. For instance, in this Python shell over here for object detection and recognition, these are items that it has added to the screen, is seen on the screen, and added it, and then said it out loud using the VR3. And then some items were removed. So as items are removed, I add a 100 to the number and pass that to the Arduino, and the Arduino knows that if it's under 100, the item's being added, so it says added. Otherwise, if it's over 100, it knows it's being removed. So that's pretty simple there. Over here, when I do the GUI, you have different options and button controls that you can do to control the robotic arm. You have degrees that you can select of base movement from 5, 10, 15 degrees. You can go left or right, up or down. You can do an auto sweep that goes from 0 to 180 and 180 back to 0. There's a random scan that scans 6 different positions and pauses 3 seconds at each position. And then there's a reset, which resets the arm back to the resting position. The degrees of movement are shown here as you go up or down or left or right. So let's select 15 degrees and let's go left, and you'll see that the base is moving 30 degrees, 45 degrees, and then we can go back right. The elbow is what moves, the shoulder and wrist. I didn't take that into consideration. The arm can go up, and you'll see the elbow now says 15, the arm now says 15. We go up, we go down, it moves accordingly. If we move up, we can then do reset, and these all reset. Now you can see the light here on the sofa is getting kind of dark because the ambient light coming through the window. So it's finding items as we move left and right. We can do an auto sweep here, and you'll see behind here it comes up, and it's now just scanning left or right, looking for objects. If I had a better video processor, like a GPU or a VPU, it would do this more in real time, but there's a 4-second delay between finding the objects and running it through the cascade to detect what the item is. So I'm getting overtalked by. There we go. So it's going to go all the way back to 180. And here it is back at the resting position. So there's also one last option here, the random scan, which will go 6 different positions and pause for 3 seconds. Hopefully it won't bang itself up here, but we'll go ahead and give it a try. These numbers will randomly change, but they do not correlate to the actual degree of the arm. So it's still moving.
All removed.
Now, I did not do a dining table or anything like that. There's 80 different objects to detect. I did maybe 24 basic ones,
Chair detected.
like a chair, a clock, a laptop, a mouse, a
All
bowl,
detected.
a remote. There should be a
Remote
bottle.
detected. All detected.
We'll do a reset here just to get the word. Now you can see where I do reset, the code shows up down here. If we do arm up, and if I do a right, I should be able to see the chair and the bottle. I think it'll find those. If I can aim it correctly.
All removed.
Well, we may not be able to see it
Remote removed.
because
All
there
removed.
it is. Let's see if we'll find it. It might find something up here like a shrub or something. I'm not really sure.
Bottle detected.
There we go.
Chair detected.
Chair in the corner it found. So it's real basic stuff. You can code all 80 if you want. Some of them are like
Bottle
bicycles.
removed.
Some of them are forks and knives. I didn't want to do all those. So again, this all kind of started with the ABBA. There was
All detected.
oh, it's still talking. So
Remote detected. All detected.
there we go. And this is the percentage of accuracy up here, just so you know. It's 99% accurate that it's a remote. This is 82% that it's a bowl. So
Chair detected.
I found the chair in the background a little bit back here, which is good. Lastly,
Chair removed.
why I did this was basically there was I heard that you could scan an image, and with 25 lines of code, of Python code, you could detect faces. And so when I started researching that code, I found that there was one that not only did images
Chair removed.
or photographs, but also did real-time video, and that's what I used for the foundation of this processing here. Then I added the robotic control using a GUI with a camera on the robotic arm. And so that's kind of where all this started and eventually
Chair
ended up.
removed.
See, the chair is just out of frame here, so it keeps seeing it and unseeing it. Here it goes again.
Chair removed.
Removed it. So, all in all, this has been a very interesting project. I've learned a lot of Python, and I want to use more Python with the Arduino modules, and that's what I'm going to do in the future. So let's look at the
Chair
code.
removed.
And the code will consist of 4 programs, so I'll try to go through it in a timely manner.
This is the first program of 4 programs that are used to run this project. This is one of 2 Python programs. It is the Gui interface that controls the robotic arm. And during the recording, I'm not so sure the GUI interface was easily seen because I did a side-by-side view and it kind of crunched the video a little bit. So I want to show you a picture of the GUI. This is it right here. This is just a screen snapshot, but it's what runs. And there are different options here with the GUI. You can change the size, the background, the text, anything you want. And that's what's really nice about the TKinter library for Python, is that you can do these custom little windows, and it's very diverse and very powerful little program, though it is hard to program to a certain degree because I'm kind of new at it, but I kind of got the knack a little bit. So I wanted to show you the GUI, and so you can kind of see it more clearly. Basically, we have the arm control up, left and right, and up and down. And when you click these buttons, the degrees that you have selected over here are added or removed depending on which way the arm moves, left or right on the base, or up and down it goes positive, and then down goes negative. Here we have some little modes that I kind of just was playing with, an auto sweep that goes from 0 to 180, then from 180 back to 0. And it just says on and off, and it just does it briefly. It's not really linked to these buttons, but as soon as you click it, there's a little time delay saying on and off. I would like to have it in real time. that would require two-way communication, serial communication, and then that slows stuff down because as you send to the Arduino has to wait until it gets some data, and then when the data is sent back to the Python module, it has to wait, and so there's a lot of waiting, and my laptop just wasn't powerful enough, so I kind of just faked this a little bit, but if you wanted to do that for your program, you definitely could. It wouldn't be very hard. Lastly is a random scan that just randomly spits numbers here and moves the robotic arm in a random fashion between about 30 and 160 degrees. And again, these are just for display. These will randomly change, but it doesn't really correlate to the arm. Again, if you had two-way communication, you could actually make this legit and have it show the degrees that the arm's set at. And then I have reset arm. That resets the arm to the resting position. And one thing that's odd is the resting position for my Brachio robotic arm. It's kind of noisy. You probably heard it in the video, the intro video. You could hear a buzzing, and that's what that was making that noise. It was kind of annoying, but that's just the way it is. It's not a very expensive robotic arm, but I wanted to get one, so I actually may do more in-depth video on that later. So that basically describes the GUI here. It's very basic. You can make it as complex as you want. There's all sorts of different buttons and rollover features and colors the buttons change and the font, and I mean you can get really crazy with it. I just wanted to do a basic window, and then from there you can add on to it or subtract stuff from it, expand it, whatever you want. So let's get to the code. Here's the code for TKinter. That's the library that actually makes the GUI interface. So TKinter we imported here. Serial communication allows us to communicate to the Arduino. Random I needed for the generate random angles in the random scan feature. And then the subprocess time and OS, I'm not sure those are actually needed. I have not checked to see if those are necessary. I think they may not be, but I did include them just in case. I believe there may be a pause. We'll have to look down the code. So you would need the time feature for pausing, OS and subprocess. I'm not sure those are actually needed, but they may be needed by TKinter or Serial. I haven't removed those. I just left them. So we get down into the notes here. I instead of having a notes file, I just kind of included it in the code. And here I talk about, I show the website where I got information on how to code radio buttons and arrange the radio buttons. I was interested in maybe doing a background image like some sort of stonework in the back, but I just wound up doing what's called a powder blue background on the GUI. Here's how you pass variables. That was something I needed to research. There was a breakthrough on the passing variables. There is an option, which I'll show you down below, that allows you to declare a variable, and when you click on that button, it passes the variable to a function, and then you can process it there. Well, I was having problems. So I actually found a website where it's not so much the button click that passes the variable, but the mouse button that you choose sends the variable. And since I always use the left button to click, that's what sent the variable, and that saved me because I was stuck for a long time on that. Here's a Hindi calculator. It's actually a calculator by some guy that speaks it in Hindi, but he kind of shows how to clear a text box, a box that's showing some text, and then replace it with existing text. So that's something that I will discuss later also, but that saved me too. So there's little glitches as I had to figure this out as I went along. There was a problem with the on-off box not updating. I would click it on, it would stay on. And this website here showed me how to click that. You basically do an update. but not everything needed to be updated. So I'm not sure why. Sometimes it works and sometimes it doesn't. Like I said, TKinter is a little bizarre. Here I say I wanted control placement of buttons and text boxes and etc. I wanted to be able to control exact X and Y coordinates. Now, it's written that you shouldn't really do this, but I wanted to do that. So I wound up using text boxes and not enter boxes. And otherwise, I would have had, if I used enter boxes, I would have had to use a grid system, which you'll see in the Hindi calculator. He uses the grid system, and you're kind of limited to where things can go. I wanted to use the place command that allowed me to specify the XY coordinate. And the XY starts up at 0, 0 in the upper left corner of the screen. There's lots of duplication. When I coded this module, I could move some of the function into the Arduino write function into a function instead of declaring it over and over and over. I could also do that with clearing displays, and I could just pass variables. But I basically, since I'm learning Python, I wanted to have everything laid out nice and cleanly so I could see what was going on. And I'll show you down below where there's a ton of repetition. So this is not an A+ program, but it works perfectly, and it works the way I want it to. So that's what I chose. I did want to mention here that in my IDLE for Python, I chose the Consolas font because it puts an X through the zeros, and that makes it easy to distinguish between an O or a capital O. And I just wanted to point that out. You'll see here's a 0 here, and an O over here, and a capital O here. So if you're coding, that might be nice to have, but I do it to show you the difference, so that when you're watching this video, you can easily tell that this is a 0 and not an O. Moving on, there are two values that are passed to the Arduino Mega. The TKinter object GUI here is what sends, I'm sorry, not to the Mega, it sends the code to the Uno, which is connected to the robotic arm. I use an Arduino Mega for speaking using the VR3, the EasyVR3 module. So there's two boards used here. This module communicates to the Uno, and I wanted to make that clear because I'm passing two codes serially to the Uno. The first code describes what type of function we're doing, whether it's a radio button selection, then the first code will be 0. If it's plus or minus, it's a left arm movement. If it's a plus or minus 2, it's an up-down movement. If it's a 3, it's a reset function. If it's a 4, it's an auto scan mode function. 5 is a random sweep motion. I limited it to 5. Using this little 0 through 9 configuration, I could have up to 10 options. But if you needed more options, you could go A to Z also, because basically 0 through 9 is passed as a character. And I tried to stay away from dual character transmission. It gets a little tricky when a single code has two characters. So I wanted all the codes to be single character. I wanted all the values to be single characters. So basically, if you needed more character controls, you could use A and Z, and I wanted to keep that in mind for future. I may want to do a lot more features. Lastly, the values are the degree value is coded as 5, 10, 15, and sent as a character to the Uno. So now here we get into the code. The Arduino serial is part of the serial library. You have to set the COM port, which you can find in your Arduino IDE down at the bottom right corner when you actually connect. This may have to change sometimes, because when you connect the Uno and all these devices, sometimes these COM ports change. So you may have to come back and change this now and then. And so here we start our def statements, which are really function statements. I have only one def. It's called callback, where I pass a value in a code. It passes the degrees first, and then it passes the left-right sweep functions. I declare these values global because I use them in other places. The whole sum stores the running total of degrees, and these can't exceed less than 0 or over 180 for left and right, and its whole sum is the same thing for up, down. Degrees stores the current radio button degree selection, the 5, 10, 15. If code equals 0, then degrees equals 0. I don't want to go below 0 here. If code is 1 or -1, we have a left-right movement, and we take the hold sum, because I need to store the hold sum. I need to store the running left-right total number of degrees so that I can display it down below in the text box. And I multiply it by 1 or -1, which is actually the code that's passed. So if I'm going left from 90 degrees in the resting position, I multiply it by 1 and add the degrees. If it's negative, I subtract the degrees because I multiply -1. And then I check to see if it's less than 0. Otherwise, it's 0. If it's greater than 180, I store it in the 180. I store 180, so it forces it to set it to 0 or 180. Here we have a text box, and I have multiple text boxes. This is text box 1, text box 3. And we clear the text box with this command. This says start at position 1 and go to the end of the string that's displayed and delete it. And then starting for text box 1, insert the value hold sum, which is stored up here. And that every time it comes through, it will update the text box 1, and it will do the same thing for text box 3. So these text boxes change. And I think right here, this is text box 1, 2. These are text box for the base would be 3, because as I move left, right, I change the base. This is text box 4. As I go up and down, the elbow changes, and then these sweeps change these boxes accordingly also. So all these text boxes have to be updated as we conduct different functions. And this is an up-down function. It works the same way as the left-right. I check for 0. I check for 180 degrees. I update the appropriate text boxes. I print out a little debug message to the screen to make sure as I'm pressing stuff it's working correctly. Down here, code 3, this is for a reset function, a debug message. Now, with the, I probably should go back up here. I got a little ahead of myself. Here I do the debug message, and then here's Arduino serial write, not a print, but it's a write. I convert it to a string, and I send the degrees. I then send and this goes along, this sends a character of the degrees as a string, and then to the Arduino, and then I write a comma, and then I write the up, down, left code, whether it's a 1 or a -1. And then I send another comma. And what that does is in the Arduino code, I scan for a string up to a comma. And the first one will be the degrees. And I set that like to data 1. And then I scan the next string up to a comma, but not including a comma, and set that to data 2, and then I do a string init. I convert the degrees from a string to an integer. I convert the code from a string to an integer, and then I process it on the Arduino. I pass those degrees onto the Brachio library, which has a single string that allows me to move all the servos at once, given the angle that I want to set it to. So that works out really good. This whole program, or this whole project, I had virtually no wiring to do. The Brachio comes with a plug-in module like the EasyVR3 that plugs right into it backpacks to the top of the Uno, and same with the Mega with the EasyVR3. I just had to connect things up, find out what the COM ports were, and I was good to go. So very little wiring in this project, which was a relief. Anyway, that was just a sidebar I wanted to mention. Moving on, we have the up-down module, which is exactly the same thing as the left-right, except here I have to divide by 2 in order to get to get 1, and then I multiply by the degrees and I change it, whether it's up is positive and down is a negative number. So if code was -2, I'd have a -1 times the degree. That'd be down, be a negative degrees. Store it in sum2, process sum2 for 0 or 180, reset the boxes, print the debug, convert it to a string, send it over to Arduino to do its thing. So that's basic. So this could all be coded into a function where you just send the different codes and different things would happen. I wrote it out and I just did if statements. You could do if-else statements. It gets a little tricky. I just wanted to keep it simple. It's like a giant case statement. I could do some sort of case statement. But anyway, I didn't. I just chose to do it this way because I'm still learning Python. Here we have a code 3, which is a reset. We send the degree and codes over to the Arduino. We update all the boxes that display all the angles on the GUI interface. We add here hold sum and hold to. We reset those to the resting position so that left and right and up and down can process it again. If it's a code 4, we do a sweep. We clear it. And what was interesting is here I had to do an update for some reason. It was very bizarre. I do a pause here for 2 seconds because I wanted to display the on message for a little bit while it's sweeping, because it takes probably 15 seconds for the sweep to conduct, and I didn't want the on-off to go on-off really quick. I wanted to kind of show that it was on for a while. I could have paused this even more. I would like to have this make this real time so that when the sweep starts, I mean, when you press it, it goes on, and when the sweep is done, it comes back and displays off. Unfortunately, I couldn't get that to work very easily without doing two-way communication, and I don't want to do two-way communication yet, at least not with my laptop. But, so this simulates it. We come back here for the Arduino serial write. We convert it to a string, send the degrees code. It does its thing. It does the sweep, and then displays off. Here we have the random scan. It updates the corresponding box, sends the information. We pause for 2 seconds to show the on, and then eventually it'll say off. And then here we from range x1 to 5, we update this with random numbers. I actually do a random integer from 1 to 181, not including 181, but including 1. I didn't go down to 0. I didn't think that was really necessary. So it goes from 1 to 180. It just shows random numbers, shows 5 of them. It pauses 2 seconds down here between random movement, and sends the data to the Arduino up here. But the Arduino actually does the whole random thing itself. This is not, again, this is just kind of a display only. And then coming on, the last thing we do, this is outside the def statement. So we're done with our little function call here, which they call methods. This is a method, not a function, but they call it a method. So outside, this is the whole description of the function or method. So now we're back to our code. We set a root to TK, TKinter. We set the size of the window. We set the color to powder blue. I did that for my wife because she's a big blue fan. That's her favorite color. Here we have radio buttons that are declared and that they're blank. We zero out the hold sum 2, and the degrees. We give the GUI interface a title, and then this is the creation of the buttons. They're powder blue, Arial font, size 10. Here's the text. I place that label where I want it. I then also have another button. This is for left, right. This is for up, down. This is the text. These labels up here are the text boxes. These are the buttons here for left, right, and here I give the height of the text box, and I give the position of the text box, and then I clear it. Lambda here allows you to pass a variable and call this. I tried to do that. In some cases it worked, some cases it didn't. And that's where you get this button 1. I'm binding the left click button because if I don't do this, you can, up here in the button command, you can have, I think it's up here in the button, you can do a value equals, so that when you click the button, it's supposed to do something, but it doesn't. So I had to declare another line of code here that linked it to the mouse button and not the graphic GUI button. And this worked for me. So I did all that for all the different functions. Here's the arm up and the arm down function. Again, the mouse button left. I guess you could do a mouse button 2, which would be the right button. So you could have different buttons that would launch different functions or methods. So here we have our callback function. I'm sending a 0 -2 for down and a 0 2 for up. I send a 0 1 for left and then a 0 -1 for right. The 0 again is the radio button. The other side is for movement of the arm of the robotic arm. Down here we have the reset and auto sweep and random scan modes. Again, I set the text. The text says mode. I'm putting a label at a very specific location. Here's the reset function. It does the call to the module, the function above, sends the appropriate codes, and again, it's linked to the mouse. Here's a text box that says the word off, which is kind of initializes the box also. Here we have the radio buttons that describe the degrees that can be sent from 5 to 10 to 15, and here I actually send the values 5, 10, 15, and you'll see that these are offset. When I do a callback for a button, it always starts with a 0 and then has a number. Here, for radio buttons, it starts with a number and sends the second value as a 0. And thus, I send the actual 5, 10, 15, the number of degrees that we need to move the base or the elbow. They're linked to the mouse button also, and then I place them at very specific locations. Here, lastly, we have all the degrees that are shown by the arm, base, shoulder, elbow, and wrist. And I didn't do the second wrist or the gripper. I could have added those also, but I didn't. I didn't really use those in this project, so it'd be easy just to copy this. And again, all of these could be set up as one large function so that I don't duplicate the code. You can kind of see that there's a lot of code duplication here. This would be really easy to make it as a single function, but I decided not to do that. So it's a much larger program, but it was easier for me to debug. In the future, I'll start to whittle down this code so it's a lot less. Again, here I set the font, powder blue. It's a label. I position it where I want. I say the arm, and then do a carriage return to bring the degrees below it. Here's the label for base, and then here's the text box for the base. We prime it with 90, 165, 0, and 0. That's the resting position. And then I do the same thing for the shoulder, elbow, and wrist. And then the only part of the program that's really the main program is the loop, and it just loops through this. So that is the first program that does the GUI. It interacts with the robotic arm and the Arduino Uno and the Brachio motor drive board. So or module. That's the first program. This is the second Python program that is part of this project. I want to go through these programs quickly, but not too quickly. I want you to be able to follow along and then understand what I did. A lot of this program, specifically this object recognition Python program, I didn't write. I actually got it part of that ABBA facial recognition. This is part of the facial recognition that actually has the web, not the web, but the video camera portion included. So I kind of took this and then just stuffed some code in to do the processing I wanted. So a lot of this I don't fully understand, and I'm not going to be able to describe it maybe accurately. I'll do my best as far as I understand, but most of this program I did not write. So let's look into this, and I'll try to go through it the best as possible. Here we start out with our importing our libraries. Serial is, again, is for communication with the Arduino. NumPy you need, or NumPy you need for number and array processing library. I found out that this argparse is for parsing command line options. I did not do command line options. There's a whole slew of them here you can see. I really didn't get that to work so well, and I didn't like how that you had to go out to the shell to run it. I wanted to run everything just using the run module command. And so I just ignored all these commands. But I did leave the argparse in here because I'm not sure, since I didn't write the program, whether these variables were set somewhere that needed to be somewhere else, used somewhere else. So I left them in. CV2, which is Open CV, which is Open Computer Vision. This is the main library for computer vision usage, and it's very powerful. It is what does the object recognition and detection, and it is very powerful. You combine CV2 and NumPy, and you can do some really amazing object recognition detection, real-time stuff with video or images. And so that is something that is interesting to know about. In addition, when I downloaded this code, you'll see here it talks about a YOLO 3 Coco and some labels and stuff like that. So we'll get down into that, but there are other files that go along with this code that I had to include, and I'll talk about those in a second. Here are some flags you need to set. I don't know what they used for, but it's just blanking out an array. And then here obviously is our Arduino serial COM5 setup for the Mega, the Arduino Mega, in order for us to send codes to the Arduino to be spoken by the EasyVR3. And this COM port will change depending on what your Arduino is set at. So now this is the start of the program, the main, and it has a bunch of arguments that are supposed to be set up when you type in the Python name in the shell. When you run it in a shell here, like I said, I didn't do that, but there's a lot of things that need to be initialized, and it also, I think, still sets up these default parameter file locations. You need a file called YOLO v3.config, you need a YOLO3.waits, you need a YOLO3 Cocoa directory. So it still reads all this stuff, I believe. And YOLO, you see here, stands for You Only Look Once, version 3. And these are all files that are in this directory from your desktop. I'm running these Python programs. Well, you can run it from your desktop, or you can run it from a file that's located on your desktop. And if you run it from a file on your desktop, or in a directory from your desktop, then all these other files, this one here, whoops, this one here, this one here, this one here, all of these have to be located in this directory for this object recognition detection to work. There's actually a lot of files that are used. There's a waits file here that is about 250 megabytes. It stores all the image profiles. What does a remote look like? What does a chair look like? What does a clock look like? What does it not look like? And you can actually, it's called a cascade. And you can write your own cascade, but it's very difficult, I think. But I may try doing that. Then you can have your own images that you want to trap for. It's like a giant case statement for images. And it slows down my laptop because it has to go through that 100 megabyte file for each and every scan. So that's why you need a good graphics or video processor, a VPU or a CPU, because this is a huge file. And it can be even bigger if this guy only coded 80 objects. And those 80 objects, I believe, are listed in the Cocoa labels file. So you can change the names and basically make it whatever you want. But those labels there's an index that is returned somehow from the waits. So once it finds it detects an object. That's the first thing. And then the second thing, it recognizes an object. And that object is recognized in this waits. And it gives a percentage, like 79% certain or 90% certain. And there's an index that it generates that says, okay, number 1 is a person, number 41 is a clock. And it sends those indexes back out. And I'll describe this more down below. And those indexes are an index into this Cocoa labels file. And the Cocoa labels will just have, the first line will be person, the second one will be clock, the third one will be remote, the fourth one will be chair, and you'll get an index into that label. And that's how you know what you're looking at. And so that index is important because I compare those and I check those and I send those over to the Arduino Mega for like a case statement. I think I use if statements though again, because that way I can trap it easily and debug it. I should mention here again, I'm sidebarring. When you start trapping for these indexes, you can only send data down the serial port because I'm running the GUI and I'm running the webcam. I can't use the serial for output from Arduino. That was kind of tricky, and I was never certain because I can't open the serial monitor on the Arduino. It'll give me an error. It will say that the serial port is being used. So how do you check to see that what you're sending from your Python program to the Arduino is actually the correct data? That was difficult. That's why I set up the LED flashing light and solid on light. That allowed me to verify that when I sent a character, say ID 41 that I knew was a clock, because it converts the 41 integer into a character and then sends it down the serial port to the Arduino for processing for the EasyVR3, I had to have the Arduino flash codes to verify that it got, first of all, it got a character, and second, it converted that character from a character 41 to an integer 41. And what I wound up doing was I would send the character, it would flash, it would tell me that would tell me that it actually read the character, and then I would take that 41 and I would multiply it by 10 to get 410, let's say, or I would add 100 to it, and then I would have an if statement that would trap for an integer 141 or 410, and that would flash 5 times or stay on solid for 2 seconds. And then I knew I actually got the character that I sent. I would print it out here in the Python saying, sending a 46, and then I'd watch the LED to make sure that it stayed on when it was trapped, when the if statement found a 46. And so there was this weird communication for a long time that was not working, and it was really tough. So it's not easy sending data one direction and with the Arduino not knowing what you're getting, but I was able to finally do that. So hopefully I've solved a lot of that problem here for you so you don't have to deal with it. But anyway, so getting back to the code here, all this code I didn't use and I didn't write, but I left it in because you do need the directories and stuff. And so I think this is where it initializes these directories. So I left it in. We come down to here, and this is kind of part of parsing. This is for parsing the string in the shell. I didn't use that. Here, if it needs the YOLO version 3 models, it would, I guess, download it here somehow. Again, I've already downloaded it, so I didn't use this. Here it opens the labels for cell phone, person, clock, etc. It opens it and sets all of these variables. I guess it's reading here to the labels variable. Not sure how all that works really, because I'm not sure what flags and I'm not sure of exactly how everything works in this. Here are the colors. This is for initializing the boundary box. It says here for each item detected. It sets up the size and it makes it a random color. So that's basically what it's doing, so that all the boundary boxes aren't the same color. So, okay, that's pretty easy to understand. It says here, load the weights and configuration to form the penetrated pre-trained YOLO 3 model. I'm not sure what this is. This is DNN, stands for Dynamic Neural Network. I'm not sure how that works. It reads something here, some flags and weights from this file. This is a file somehow that's labeled up here somewhere, I believe. So again, I'm not sure how that works. It's pretty tricky, but it works. So you get the output layer names for the model. Not sure. Again, here are the layer names, and then the layers somehow some sort of array here. I'm not sure what the layers are. It's used for the CV, the object Open CV, Open Computer Vision library. I think. I don't know. So this is where this was part of the code. So starting the inference on the webcam. You can do it on the camera on your laptop, or down here, I change video capture. The laptop is 0. What is the USB camera? Sometimes if there's no picture, you can swap them. But down here is where all that is initialized. The count that holds the rounding found objects is set to 0. Old count set to 0. I keep the previous count so I can compare something being added or deleted. Is it the same? Old classified IDs, again, these are, and removed class IDs. These are the array of indexes used in the YOLO 3. It holds the array of the original group of class IDs. So if you have 3 objects and you want to see if you find another object, or if an object is removed, you compare old class IDs to class IDs, and then you'll know if there's more, you've added. If there's less, you've subtracted, and you can kind of find out what you subtracted and what you haven't. And that's what these are used for. So we come down to here, while true, it loops forever. it reads a video frame, which I guess that's one frame. It sets the height that it reads. I'm not sure, from the beginning through 2. I don't know. Now here, I set up a count. Nothing has been found yet, so it just grabs one frame, and this is all the information it grabs, I guess. So here, excuse me, we have object count is the length of class IDs. How many objects do you actually have that you found? Did you find 1, 2, 5? Well, class IDs will have a number, comma, another number for each and every object that it found in the cascade that I mentioned above, the big file. And I set that to object count. I say count equals count plus 1. I bump that from 0 to now 1, and I keep adding to that. And I say here, if old count is less than object count, then we know the old count has 5 items. And if the object count is less, it says here, let me just read it. If the number of class IDs is less than the new count of class IDs, then the object was added. For instance, if the class IDs that we had before is less, this should say old class IDs, but basically if you have 5 class IDs and that's less than your new class IDs of 6, then you've added 1 item, and so you come into the added portion of this if statement. You print the class IDs that are added. Basically, this is an array. It'll print them all out. You'll have a 0 or you'll have a 1 for a person. You have 41 for a clock. You have 35 for a chair. Blah blah blah. So that prints to the screen. I say something was, as long as the length is not 0, mean empty. We print added, because you could have nothing and then it adds nothing. So I wanted to trap for that. And then it would say added, but there wouldn't, as long as it's not 0, there's actually something, then go ahead and print it out what they are. And this will loop through all of the array items in the class ID, and then it writes each number, each value as a string to the Arduino. And that's what this does. And then I set the old number of class IDs, the count, to the current new class IDs. So I update that. And then this if statement's in line with this if statement. If the old count is greater than the object count, then we now have the reverse scenario where a class ID was removed. Meaning if this is larger than the incoming, then, and we do a comparison here, we say the old class IDs, does not have class IDs, then the removed ones, and I'm adding 100 to them, and I'll explain that in a second, are equal to the removed class IDs. And this basically allows me to take this statement that contains the removed class IDs, and then this statement allows me to add 100 offset. And why is that 100 offset important, and what does it mean? First, if we have a 41 for a clock and a 35 for a chair, it's now a 141 for a clock and a 135 for a chair. That's important because when I send this over to the Arduino down here as a string, the Arduino is going to process anything over 100 as something removed. And that's important because I need to say the word removed so-and-so. And that's how I toggle between added items spoken and removed items spoken. So that worked out actually quite well. I was very proud of myself on that. So anyway, getting back up here, we add the 100. We print out the information to the screen as a debug. As long as they're not 0, we say removed, and then here we send them. We update the old object count. We decrement the count because we've removed some items. And I probably might have wanted to update the count because one thing that's interesting, not just with a -1, but with the length of the removed class IDs. I did not do that like I did up above, the length of class IDs. Might have wanted to done that looking back. again, a little tricky because I'm using someone else's code up above, but basically what happens, excuse me, what can happen is you can actually subtract two items at once or read two items at once. I kind of catch that the second time around because if there's two items removed here, the length up here will change, and I'll eventually catch up and mention that it's left or been added. So it needs a little bit more work, but for the most part, this worked really well. And there was actually an else statement down here that I removed that could never figure out really what that did. I probably should have left it in, but I didn't. It was just 3 lines of code, and it didn't really seem to do much of anything. Anyway, so this could be improved a little bit. And this could probably be a function or a method that you could code that would, you just pass a variable for adding or removing and then do the exact same thing. This is fine. So here I'm not really sure how this works. This was allows you this allows you to pop the image to the screen. And the way this imaging is done, it builds it all up in memory. This frame read and stuff, you're kind of doing everything in memory. It's not really showing on the screen. And then this pops it to the screen for you to view. Down here is the last statement. If this hex offset plus the letter Q allows you to exit the program. I never really used it. I probably could have taken it off. I just did an escape and shut the window down. This releases the video so that other devices on your laptop can use it. And then this destroys all the windows and closes it down. I kind of never really did anything. I just shut the damn thing down. So that is the video recognition and detection portion of the second Python program. Again, I didn't write a lot of it, and I'm not sure exactly how the video processing works or how it goes through the cascade, the YOLO cascade, but it worked. And so I kind of just stuck some code in and went with it. And so I did have some difficulties, and sometimes it would act kind of irrational, had problems with that, but overall I got it to work, and I'm pretty happy with it. And I think over time I will massage this code a little bit more so that it works faster, smoother. Hopefully I'll have less delay going to the screen. It'll be more real time. I will try to include, when I upload to the web, the code, the file, the sketches and modules, Python modules, I'll try to include a text file with all the websites. I didn't include all the websites on this. It was rather lengthy, and so I'll try to include that up there too. This is the third of 4 programs. It's the first Arduino program, Sketch. It's the TKinter object detection robotic arm control sketch for the Uno. This portion goes over to the Uno to control the robotic arm. And so we have a couple, starting off here, we have a couple include libraries, the Brachio robotic arm library for processing the robotic arm, and then the servo library for moving the servos in the arm. I use the Arduino 1.7.11 IDE. That seemed to work the best. And so the Arduino that we have up here is not the one that I used. Down here we have the initialization. The string value is holds the value input sent from the Python program. This is the comma that's sent. Here's the code string that is captured, because in order to use the string to int, you have to store everything in a string. So that's what I did here. This is the data that's coming in on the serial port. Here we have the data value initialized to a number so that's outside the range. Same with the data code. This is part of the conversion. This will be the value that we test for. Here's the old base value, old shoulder, elbow, wrist, and wrist 2. This allows me to set up the resting position and pass this using a command to the robotic arm that allows it to move all the servos at once. Coming down here, they set up the servo library. This was part of the library that I used with the Brachio arm. I didn't set that up, so but I left it in. So here's the setup portion of the code. We set up our serial port, and then while the serial is not available, while there's nothing there, we wait. We do this little command. We just sit here and wait. And once we get something, then we move on. Basically, we set the serial timeout to 5,000, which is 5 seconds. There's a lag time between the Python program, which takes about 4 seconds to run as it grabs a video image. And then there's a timeout that occurs with the robotic arm or with the serial port. So I had to bump that up so that it had enough time to actually sit there and wait to receive something. So I changed that. Here's the pinout mode for the LED. I set it to low. Here's some information on the Brachio function down at the bottom of the code down here that tells what all the M1 stands for base, M2 stands for shoulder, M3 is elbow. These are variables that are passed to the arm to move it. Here we set up the beginning of the Brachio arm, sets the data rate and bits per second. This was coded in. I guess it could be 9600. I didn't change this, so I just left it. I guess this just starts the incidence of it. Here we move the robotic arm to its resting position. Normally there's a milliseconds you can give here at the beginning, but again, I didn't write this, so this is all part of the code that I used from the examples, and I just inserted my code. Down here is the loop. We've ended the setup portion. Here's the loop. And while the serial available is equal to 0, wait for incoming data to arrive. So basically, serial available means if there's nothing there, if there's nothing waiting, it's not what it is there something? So for instance, if you send 5 commands separated by commas, let's say, and the data is 1, 2, 3, 4, 5. Let's say the data's 10, 20, 30, 40, 50. The serial available will be 5. It won't be 10, 20, 30, 40, 50. It won't be the actual data. It will be the amount of data. I hope that's clear. So when it's equal to 0, that means there's no count in the serial port currently. But as soon as you get some items in, regardless of what they are, let's say there's 3 of them, 4 of them, 1 of them, this will then change. We'll delay for a second, not even a second, a fraction of a second to give the serial port time to get ready again. And then we move on with our code down here. And this is just a note for string to int. I wanted to save that information. That's a website. I thought that was pertinent to this because it did save me when I was having problems with the code because, again, like I mentioned in the earlier Python program, I couldn't open up the serial monitor because it wouldn't open because the serial port's being used by the Python video and GUI, and so it never opened. So I never knew if I got the right command or integer information or character information or anything. It was really kind of an odd situation, but I was able to resolve it. Here we have the values and the code information. I store that here so that I know what I'm referring to when I'm down here working on designing the code. Here, while serial available is greater than 0, while there's data, we continue to loop. Right here, we in string. Again, remember it has to be a string. We serial read in string until a comma, but not including the comma. Give it a fraction of a second to process it, and we say the data value is now you take that string, we convert the number to an int, to an integer, and we store it in data value. So we take the in-string value and convert it to a data value. And then we do the same thing with in-string code. Because I'm sending a string number, comma, string number, comma. I'm sending two sets down from the Python to the Arduino Uno here. And so it's the control character that's trapped is a comma, but the read string, and you'll find out more information up here, reads up to but not including that character, which is really nice, and that's what really saved me. We delay here a little bit to let it process, and then we convert the data code of the string to an integer and store it in data code. Once we've got our two numbers, here's more string manipulation that I thought was interesting, so I put it here because I started to use that down here. If the data code is a 1, we move left, and we turn on the LED. The old base value is equal to the new data value. And the data value, what is the data value? It's the number of degrees. That's why I have that up there. And since it's since we're moving left, that means we're going from 90 down towards 0. We subtract, and it continues down. And if we get to 0, and we've subtracted past 0, we reset it to 0. So we never go past 0, which is important. Then we move the arm, the old base value, which is whatever we moved it to, plus we retain the old elbow value. So we don't want the elbow value, we don't want the elbow to, every time we go left or right, to go up or down back to the resting position. So we want to maintain that old value. So that's why I keep all these old values up above. Up here I keep all the old values so that the arm doesn't change position when I make this call for a particular movement, whether it's left or right or up or down, whatever it is. And basically it works the same. So here we've moved left. Right, instead of subtracting from 90, we add to 90. Over here I say that. And then if we get over 180, we just set it to 180 and we're done. We move it and it moves. And so it's the same, and then we turn the LED off. So we have it on while it moves, and then we turn it off so that we know that it's actually got the command, processed it, and it works. Because I did a lot of debugging without having the arm hooked up. I didn't want the arm flying around all this time. I just went off of the lights, and I knew the lights would work because when I moved up or right, it was trapped here in this if statement, and then the light would go on and off. And I could change the light flashing or staying on or whatever to indicate whether it was an up or down or right, whatever I wanted. Because again, I couldn't open up the serial port. So I had to do it with lights. And that really saved me. That being said, you can see the right, the up, the down. The code is all very similar. Instead of being a -1, it's a -2. Instead of being a -2, it's a 3 that's passed. So I could have done this with a function using a case statement where I pass different variables depending on what function of the arm was done, whether it was down or up. I didn't do that. I just did it with an if statement because, again, it was hard to trap because I couldn't see the serial monitor. But now that I have this code working, in the future I'll use this. I will just put this all in a case statement with a simple function, and the code will shrink right down. Moving on, we have the up statement, the up movement, the down movement. It's the same thing, except instead of being the base, it's now the elbow that's changing. You can see the elbow here. You can see the base here. Very simple. Here's another, the arm reset. It just sets all the old values and back to this, and then sets the data to this, and it moves the arm here I probably should declare them first and then move the arm, but it doesn't matter. It moves the arm to the resting position and then declares it, turns the light on and off, we move on. Here's the sweep. The auto sweep sweeps from 0 to 180 in 10-degree increments, and it just loops through, moving it from 0 to 180. Here it moves, changing the old elbow value. It keeps the old elbow value, and the arm, this is the base position, moves it I, which is 10, 20, 30, 40, all the way up to 180. Gives it a few milliseconds, a portion of a second to move, and then continues on. And then this goes back. So this goes up to 180. This goes from 180 down. We reset the arm to the resting position, reset the base and elbow values. We're done doing the auto sweep. The arm random scan, very similar to the sweep, except we just move in random numbers. And that's what the random function's for. We do 6 random positions. Actually 5, doesn't include number 6. Turn the light on, the LED on. We wait 3 seconds, turn it off, restore it to the resting position, reset the values. We're done. We come down to this portion. This is the end of the loop. And basically we reset the string for the value data. We reset the string code for the code value, reset the data and the data code value to some number that's outside the range, and the data value that's outside the range, and then we start the whole process again. This is the last portion of the code. This is the function that was written by the Brachio folks that had it as an example. This is the void move arm where we pass all of these variables. Tells down here how they're labeled. There's a step delay, M1, 2, 3, 4, 5, up to 6. I do not open or close the gripper because there's a camera mounted. And here we call it, it moves. There's a 20 here that gives it it says it's milliseconds delay for the servo to move. And then here you pass all the variables. And then here's 73, which is closed. I wanted the gripper to stay closed. I wait a second for it to kind of move into position, and then that's it. That's all the code that allows it to read commands from the GUI and then process it in the robotic arm and move it into the proper positions. Again, the code can be compressed by using more functions and case statements. I didn't do that because initially I was having problems again with the serial monitor up here in the corner, not knowing what commands I was actually sending or what was going on. And I did a lot of this without hooking up the robotic arm because I didn't want the robotic arm flying around and trying to go to weird degrees and all sorts of stuff. So it worked out, and now that I have the code, I can now modify it in the future. So the code isn't as streamlined as it could be, but it works beautifully. This is the last of the 4 programs. This is the Arduino program for uploading to the EasyVR3 voice module that's piggybacked onto an Arduino Mega. This code is, there's a little bit of code here that's used for initializing the EasyVR3 that I tried to whittle down as much as possible. I'm only using the portion of the EasyVR3 speech that says out loud the object detected. The EasyVR3 can do a whole slew of things that I'm not using here, such as you can actually speak to the EasyVR3, have it recognize code words or a trigger, and have it set up stuff. I'm not getting that complicated with it in this project, but just so you know, there's a whole lot more to the EasyVR3. Beginning here with this code, I wanted to mention that I had to use the 1.7.11 IDE. Here it says 1.8.9. This is just for this video. I don't have the 1.7 installed on this PC, so I'm not actually running it here. I'm just, like I said, I'm just describing. But I had problems with recognizing the serial port with the newer version. So if you're having problems with that, you may want to try different IDE versions to get it to work. So I wanted to bring that up. That's why I noted it up here. Here I note that could not use or save memory space. The memory space for detected and removed objects, it took too long. I had to say the action in the object. What's going on here is I used to say, in order to streamline the voice command, I had a command that said added, removed, and then I would have another word that said clock, chair, and so the clock, chair, table, they were all discrete, and there was only two commands, add and remove. Well, what would happen is it would go to say add or added chair instead of saying added chair from the EasyVR3, because it had to go through its little table and it took too long. The whole program was already running kind of slow, and I didn't want that to slow it down even more. So what I did is I created an add chair, remove chair, and uploaded all those. So I had duplicate EasyVR3 wave files. It's not ideal, but it works, and so that's what I'm talking about here. Next, another note here is you must include the bridge normal in case statement down here for the EasyVR3 commander software to detect the Arduino. If you take it out, it'll still run, but it won't recognize when you go to run the software to upload wave files or sound files or sound table to your EasyVR3 module. It won't recognize it. So down here, I had to include it. There's a statement down here. Where is it? It's down here further. Down here to include it. Otherwise, you can just keep this, and that's all you need. So if you don't need to add any sound files or sound table to your EasyVR3 module, you can take this out. It's up to you. I left it in. But I wanted to note that up here. Let's see, here's some other information, website information. Obviously, here's the string to int. I needed to use it here. I just wanted to keep a note of that. So starting the program, we include our Arduino H for communication. This is part of the EasyVR3 software initialization. Here we initialize and create an instance of the EasyVR3 included here, and include the EasyVR3 module information here. We initialize the character that we're going to read from the Python serial port here. We create the string, and then we create the data. Again, what I'm passing here is the word, or is the class ID, from the previous Python program, the first one. I sent a 1 for a person, a 31 for a clock. I send a 46 for a chair. That's what I'm trapping here. We start out with our setup. And here we start our serial begin statement, set up the baud rate, and then while there's no serial data, while nothing's there, we wait. Once something shows up, I do set the timeout again like I did before. I set up the LED as an output. I turn it off. I do the PC serial begin. This is for the EasyVR3. This code is required to connect the Arduino board and the EasyVR3 module and allow the commander software to connect to the EasyVR3 module to upload to the sound table. Now, you're going to need to create your own sound table, and I describe how to do that with another video, my EasyVR3 video, which you can watch also. One thing I did do is I used a better microphone, and I used the sound table to record it using a microphone and a good speaker. And then what I did is I actually put a pillow over that so that it wouldn't pick up any ambient noise, and that worked really well. And I was thinking of including a little video clip of me showing you how you do that, but this this video is getting kind of long, so I didn't want to include that. But it's really simple. You just put a microphone right up next to a speaker and put a pillow over it and do your recordings, and it works beautifully. So moving on here, this is where the bridge modes are set up for the EasyVR3 to communicate with the Arduino Mega, and this allows you to upload the Commander sound tables that you've created to speak each object detected. I may or may not upload those WAV files. We'll see. The WAV files have to be a certain size, and there's a lot of them. I'm not sure. I'm going to think about what I do on that. The EasyVR3 here has a timeout. And then the set language is set to English. You can change this number and change it to different languages. Instead of saying, table, it might say it in Spanish, whatever you want. Void action, you got to keep this. This is a function that's down at the bottom of the program, and it's empty. I'm not sure why you have to keep that in, but you take that out, you get an error message. So possibly some other routine or function uses it that's part of the bridge mode or something. I don't know. Beginning here is the loop. While there's nothing in here, just wait. And once something shows up, wait a fraction of a second to process it. And then while there's something in there, read the character here. I probably could have used the string int, but since I'm only passing one character, I test for a comma, and if it's a break, and then I break out, and then I say the int string is that character. There's only one character I'm passing, which is the item, the object. Is it a chair, a table, whatever? And then once I get out, I say data1 is the int string to int. That's our, and I probably could have put. No, I have the int string. So what I do is I concatenate int string into int string here, and I just process it here and store that number in data or into data1, and then must subtract 1 from Cocoa label ideas. Array goes from 0 to 79. So I will pass a 1 because it's the first item in the array, but I'm sorry, but the data 1 0 is actually the item in the sound table. So I subtract the value in the sound table. So a data 1 a data 1 0 is a person. A data 1 39 is a bottle, and so we need to trap those. And we do that by, here's the string. Let me go back a little bit. Data 1 is converted from a string to an int here in data 1. That data 1 is processed here. So this is just a reminder to let you know that Cocoa label IDs go from 0 to 79. This subtraction doesn't, it's already occurred before it's sent down, if that makes sense. So this does not reflect subtracting here. We just convert the string to an integer and then process that integer. So if we get a data 1, which is a 0, we know that's a person. We turn the LED on. We play the sound in our sound table, which is a 23. We make a little beep sound, which is a 0, and we're done. And we do that for each and every item, whether it's a bottle, a cup, a bowl, a chair, a sofa, a TV monitor. These are all different values and different sound table values to speak it. A laptop, a mouse, a keyboard, and a remote, a cell phone, a microwave oven, a refrigerator. I was in the kitchen for a while, near a kitchen, so I was picking this up, so I included it. And here's just a regular oven, a clock, and so I didn't code it, but if something is unrecognized, I wanted to say unrecognized item found or added unrecognized item or object. I didn't code this in. I didn't really want to do that yet, but here's the code. And Again, there's 80 some odd objects. I've only included maybe 24 here. It was enough for this project. You can add more or subtract some out if you want. And this could be a case statement too. Again, you see repetitive code here, which is not great. But again, I was doing this without seeing the serial port, and I wanted to make sure I was handling it correctly this time. So in my next projects, when I use this code, I'll definitely whittle this down. Now, that being said, up here, I mention if data is a 0 or 39 or 41, you see that these are all less than 100. Down here, when items are, when the data 1 is greater than, as I said, 90, but really if it's over 100 or more, we know that they're removed, because that's what I coded in the Python program to send. And then it's exactly the same thing. So if you subtract 100, you have 0 for person. You subtract 100, you have 39 for a bottle. And you'll notice up here, 39 is a bottle. And so it was easy to debug this because I could see what was being sent and whether it was added or removed. And then I just trapped the same thing here. Again, this could be a case statement. It could be one giant case statement with an LED on-off function. Here I turn it on, turn it off. I could have the beep sound played. I mean, this could be reduced way down and will be in the future. But for right now, I just kept it simple and straightforward. And so that should make it easy for you to debug what's going on. So then other than that, this is the end of the code down here. Once I've turned it on and I play the command, whatever that object is, a clock, and then I play a beep sound, I then come out of that loop and I turn the LED off. I reset the in string for the next set of data. I reset the in character to read the next character number, and then I set data to 0. That probably should be 999 actually, because data 1 is actually a valid data point. But anyway, and then I reset data 1 for the next conversion from string to integer number, and then that's it. This program, this is done. There isn't really any more processing from the Arduino Mega that needs to be done. And like I said, it is on the large side because I wanted to make it simple and make sure I could debug it easily. And so this is going to be smaller in the future. This is the last of the 4 programs and modules, Python modules. So I hope this is clear. I hope that this helps you with this very complex project. You know, the object recognition detection, saying it out loud, moving a robotic arm to look and scan around a room. It's pretty powerful, and there's a lot going on. So if you find this helpful or informative, please subscribe to my channel. Please share with others. Please download the code and use it as you wish. If you put me as a note, I would appreciate it, but you don't have to. And I'm going to do more with Python and the Arduino modules and robotic arms in the future here, because I think there's a lot more I can do with it. And we'll see how that goes. Again, comment, give a thumbs up if you wouldn't mind, if you like it. And thank you for listening.